Bismillahirrahmanirrahim. Assalamu alaikum, my dear student. I am Hassan Khan, Assistant Professor Civil Engineering Department, Sood, Peshawar, and this is third lecture of Engineering Hydrology. This lecture is about meteorology. In this lecture, we will cover these contents. First, we will define what is meteorology, then we will discuss some of the meteorological phenomena like weather, climate, weather fronts, lapse rate, humidity, dew, fog, frost, and clouds, etc. etc. Before starting this lecture, let's discuss the nomenclature, the layer nomenclature in the atmosphere. Our atmosphere is divided to some layers. The first layer above the Earth's surface is known as troposphere, and this extends up to 14 kilometer height. And this troposphere actually makes the Earth atmosphere. The top of this troposphere is tropopause, a thin layer of 4 kilometer height. Above the first layer, above the tropopause, we have the second layer, stratosphere, which is up to the 50 kilometer height, and the top surface of the stratosphere is a thin layer of ozone. The third layer is mesosphere, and the last layer is ionosphere. Okay. Let's start meteorology. What is meteorology? Meteorology is the scientific study of the Earth's atmosphere. Earth's atmosphere means troposphere. In this subject, in this lecture, we will discuss some of the meteorological phenomena which are actually required for understanding some of the hydrological concepts like precipitation formation, etc. Meteorological phenomena are observable weather events which are bound by the atmospheric variable that exist in Earth's atmosphere. Atmospheric variable means some of the parameters which control the whole weather, overall atmosphere of any region. What are those parameters? What are those variables? Those variables are: number one, temperature, air pressure, water vapors, air density, and the interaction among these parameters and how they change in time. Now let's start our meteorological phenomena one by one. First of all, weather and climate. The weather and climate both are defined as the state of the atmosphere, mainly with respect to its effects upon human activity. How we feel this state of the atmosphere, how human beings feel this state of the atmosphere, this condition of the atmosphere. Now the difference between weather and climate is that weather is the short-term variability of the atmosphere for time scales of minutes to months, and the climate is actually long-term statistical description of the atmospheric condition, average over a specified period of time, usually decades. For example, if we are talking about the atmospheric condition of an area for a day, for a minute, for an hour, for a month, then we can use the word of weather. But if we are saying for decades, for years, for many years, then the word weather is not appropriate. The word climate will be used. Popularly, mainly the temperature, wind, humidity, precipitation, cloudiness, brightness, and visibility all these parameters are considered as weather in climate in common people. But these parameters are atmospheric parameter. These are not the weather. Weather is actually the state of the atmosphere. Now let's come to the third meteorological phenomena, which is weather fronts. What is weather front? A front is defined as the transition zone between two air masses of different density and moisture content. As you know, the air in the atmosphere is not same throughout the atmosphere. You would have feel in some area the air is cold and in some area the air is warm. The warm air is different from the cold air, and this difference is due to the amount of moisture content present in the air. In cold air, the amount of moisture content is less, while in warm air the amount of vapor is more. And also the density of cold and warm air are different. Now whenever there is a cold air and there is a warm air, there will be a boundary between these two masses of air, and this boundary are here it is called as transition zone. This transition zone is known as front. Now when a warm or cold front stops moving, it becomes a stationary front. Now fronts are of different types. There is a cold front, there is a warm front, there is a stationary front, there is an occludent front, but we are mainly concerning with the cold front and warm front. So if there is no movement of air either from cold air or from warm air, then the front existing there will be known as stationary front. But if the cold air is moving, advancing forward, and the warm air is stationary, then this front is known as cold front. Contrastly, if warm air is moving and cold air is stationary, then the front will be known as warm front. Now, when a noticeable temperature change and shift in wind direction are commonly observed when crossing from one side of a stationary front to the other. So a cold front is defined as the transition zone where a cold air mass is moving forward and is replacing a warmer air mass. Cold fronts generally move from northwest to southeast. The air behind a cold front is noticeably colder and drier than the air ahead of it. When a cold front passes through, temperatures can drop more than 15 degrees within the first hour. I have a very good animation for understanding this weather fronts. So let's see this animation.
Situation that happens where cold air moves in like a big wedge underneath warm air. Cold air is always heavier than warm air, and so it's denser, and it's going to tend to slide under the warm air and push the warm air upward. Anytime you have air rising upward, it's going to expand and cool and lose its ability to hold moisture, and this will give you a band of clouds and precipitation along a cold front. On weather maps, if you watch the weather on the news, you can see cold fronts marked by lines of blue teeth that point in the direction the cold air is moving. Along cold fronts, you typically have very intense local thunderstorms and rainstorms. So it might pour rain for a short time, but then quickly, usually within an hour or so, the front will have moved on. So a cold front is where the cold air pushes underneath the warm air, and you have high rainfall and usually intense thunderstorms. Now, the warm front has in common a couple of things with the cold front. One is that the warm air still goes up on top of the cold air, But in this case, the warm air is actually pushing the cold air out of the picture. So the warm air is winning, and that's how you can remember it. It's a warm front. The warm air pushes against the cold air, squeezing it out. Like imagine squeezing a watermelon seed between your fingers. It kind of squeezes out, right? And as the air pushes, it also rises up over the cold air. Rising air, again, loses its ability to hold moisture, and you tend to get clouds and rain. On long warm fronts, you typically have more mild, more mellow, more spread out rainstorms rather than really local intense thunderstorms. And if you're looking at the weather on the news, they mark warm fronts on maps with red half moons that point in the direction that the warm air is pushing the cold air. So that's cold fronts and warm fronts, major precipitation belts.
Hope you understand this video. Now let's come to the next meteorological phenomena. There is lapse rate. What is lapse rate? It is actually the rate of change in temperature observed while moving upward through the Earth's atmosphere. If any body is moving upward in the Earth's atmosphere, the change in temperature is known as lapse rate. Now, commonly, when any body is moving upward, the temperature decreases with elevation. The temperature of the body decreases with elevation. This is only for the Earth atmosphere, and we are talking about the Earth atmosphere. So it is to be clear that this is Earth atmosphere. So temperature decreases with elevation. If the temperature of any body at the Earth's surface is lower and is higher, and if this is going upward and with the elevation the temperature decreases, then this lapse rate is known as positive lapse rate. Conversely, if a body is moving upward and the temperature increases with the elevation, this phenomena, and then in this case the lapse rate will be negative, and this is called as negative lapse rate. And if anybody is going upward in the atmosphere and there is no change in the temperature of that body, then the lapse rate would be called as zero lapse rate or constant lapse rate. Now actually the lapse rate of non-rising air averages about 6.5 degrees centigrade per kilometer or 18.8 degree Fahrenheit per mile in the lower atmosphere, that is known as troposphere. So it differs from the adiabatic lapse rate, which involves temperature changes due to the rising or sinking of an air parcel. Adiabatic lapse rate means in which no temperature loss is considered, loss or gain is considered between the system and between animal body. So let's discuss what is dry adiabatic lapse rate. For adiabatic, as discussed earlier, adiabatic means when there is no change of temperature between the system and the body, no loss or gain of temperature between the system and the body. So the dry adiabatic lapse rate is 1 degree Celsius of cooling for every 100 meter rise, such that 1 degree centigrade for 100 meter rise, which becomes 10 degrees centigrade for 1 kilometer, or if you look in the FPS system, 5.5 degree Fahrenheit per 1000 feet. Thus, this is an example. If we have a dry parcel of air that rises 200 meters, will cool 2 degrees. When it descends, when it again comes down 200 meters, it will regain its original temperature. So this is what about the dry adiabatic lapse rate. Now the next one is saturated adiabatic lapse rate. Air that is saturated with water has reached the dew point temperature and is carrying as much moisture as that parcel of air is capable of holding at that temperature. When air is saturated with vapor, the temperature of the air reaches to the dew point temperature, means the vapors now are ready for converting into liquid form. This saturated parcel of air has saturated adiabatic lapse rate, which is also known as wet adiabatic lapse rate, of 0.5 degrees centigrade per 100 meter or 5 degrees centigrade per 1 kilometer. So thus the saturated adiabatic lapse rate does vary with temperature. The next phenomena is humidity. What is humidity? As you know, humidity is the amount of water vapors or moisture present in the air. It helps in cooling and heating of the atmosphere. What is water vapor? It is actually the gas phase of water and is invisible. Humidity indicates the likelihood of precipitation, dew, or fog. Commonly, there are three main measurements of humidity, that is known as absolute humidity, relative humidity, and specific humidity. Absolute humidity is actually the water content of air. How much water content is present in an air. Relative humidity, expressed as a person, measure the current absolute humidity relative to the maximum. Specific humidity is a ratio of the water vapor content of the mixture to the total air content on a mass basis. To understand these three and differentiate among them, let's consider an example. For example, in my room, there is total particle of dry air is, let's suppose, 80, and in 20 particle are of vapor. So total air content is how much? Air is 80 particle and 20 particle are moisture. So how much is the water content? Water content is 20. So absolute humidity of the room is 20. Just 20. The relative humidity in this case is what? It is actually the current absolute humidity relative to the maximum. Now, in the current state, we have only 20 particle of air, of moisture, and in this room, total number of particles which can be adjusted in this room are, let's suppose, 40. So the maximum absolute humidity of this room, which could be, is 40, but currently the absolute humidity is 20. So what we will do, 20, which is the current humidity, absolute humidity, divided by the maximum humidity, which is 40. 20 by 40 multiplied by 20 divided by 40 multiplied by 100 is expressed as for expression of percentage. So we will get how much percent? We will get 50%. It means that the relative humidity of this room is currently 50%. What is the specific humidity? It is the ratio of the water vapor content of the mixture to the total air content on a mass basis. Vapor content in the current situation are 20 and the air content is 80. So 20 by 80 is known as specific humidity. Next is, what is importance of this humidity. Now let's discuss the importance. This is a very important phenomena. Humidity is very important phenomena in our atmosphere. The vapor has magnified role in transferring water from sea to land by the media of clouds and precipitation, and then in absorbing radiation. Mainly, the humidity has two important roles. Number one is it transfers water from sea, river, and other water bodies to the atmosphere, and then from the atmosphere it comes in the form of precipitation, in form of water, rainfall, snowfall, in hailstorm, etc. So one role is the transferring of water from sea to the land, and the second role is it absorbs radiation. So now this is actually the explanation of transferring of water from sea to land. When air is lifted, it carried to a region of lower pressure where it will expand and cool. Whenever there is a water, in the water converts into vapor, and these vapors it comes to the air, and when the air is heated up, this will go upward means to the area of low pressure, where when the pressure is low upon this air, it will expand, and during expansion cooling occurs. It may rise up a mountain slope or over the front of a cooler, denser air mass. If during this cooling process it rises to a level where the temperature of this air becomes the dew point temperature, means that these vapors are now able to convert into the water or liquid form. Now, if condensation nuclei are present or absent, the dew point may be exceeded by the cooling air and the water vapor becomes supersaturated. Now, in such a situation, when the temperature reaches to the dew point, if there are condensation nuclei in the air, condensation nuclei are actually small particles of dust, then the vapor sit on these dust particles and convert into liquid form. And if these particles are not present, then the vapor cannot convert into the liquid form, and they move further rises up. And during this rising process, the temperature decreases more, and the air now becomes supersaturated. If nuclei are present, or if the temperature is very low, however, cloud droplets or ice crystal form, and the vapor is no longer in the invisible case of atmospheric humidity. The invisible vapor has another climatic role, namely absorbing and emitting radiation. The temperature of Earth and its daily variation are determined by the balance between incoming and outgoing radiation, and these incoming and outgoing radiation are controlled by the humidity. Next meteorological phenomena is dew. What is dew? On cool nights during winter, when the earth radiates heat and gets cooler, then the air which comes in contact with the cool ground also becomes cooler, and water vapor starts condensing over the grass, trees, and leaves, etc., which could be seen in the early morning. This is called dew, as you can see in this picture. This is actually the same humidity. Humidity means the vapors present in the air. Now these vapors are converted into the liquid form, condenses. Now after condensation, a few things may be developed, and which one is the dew. The next one is the frost. Now when the temperature falls down to 0 degrees centigrade, the water drops forms ice crystals, which are known as frost. If the temperature of this area is 0 degrees centigrade, then the water drops convert into the ice form, and this is now called as frost, not dew. What is fog or mist? You have seen. Fog is formed by the condensation that takes place on the dust particles floating near the Earth's surface. It can be seen during the peak winter season. As you can see in this picture is from Lahore city. The next meteorological phenomena is clouds. What are clouds? Clouds are a mass of minute droplets of water formed by the condensation of water vapors in the upper atmosphere. These are the clouds you can see in the picture, and these clouds are actually minute droplets of water which are formed by the condensation of the vapor present in the air. On the basis of the appearance and the altitude at which they occur, the clouds are classified into the following categories. Clouds are classified into 4 categories. Number 1 is nimbus clouds, cumulus clouds, stratus clouds, and cirrus clouds. Now, number 1, what is nimbus clouds? These clouds occur at low levels. They are dark gray or black in appearance. They cause heavy rainfall, as shown in this picture. Second one is cumulus clouds. They appear like cauliflower. They are often white or grayish. They are also the rain-bearing clouds. Number 3 is stratus clouds. They appear like thin sheets in the sky. They are whitish and they hardly bring any rainfall. Number last is cirrus clouds. These clouds look like the bird's feather. That is why they are sometimes called as feathery clouds. They don't bring any rainfall. So this was all for today's lecture, and again my recommended textbooks and reading references are the same as in the first and second lecture. And so this was all for today. Thank you very much. Once again, if you have any question, suggestion, any issue, you can contact me to my email hasan.782.edu.pk.